Good evening, everyone. My name is Riya Sharma. I am a PMRF research scholar from IIT Kanpur. I am currently in my PhD third year. So, today is week 5 assignment problem solving, and the past 4 lectures I have recorded it and I have put into it. So, this time also we will do the same. So, the course is thermodynamics of fluid phase equilibria, right? This is, so I'll just write my name also. My name is Jaya Sharma. I am a PMR candidate. Yeah. So, according to week 5, it was more on permutation and combination, where you learned about uh, Boltzmann permutations and energy discretization of energy. So I've taken my own questions which I'll be simultaneously writing, and I'll make you write those questions and then we will be solving it. This is the way which we have done the problem solving sessions generally. So let's do it now again. So write the first question. How many permutations or different sequences of the letters in the word cricket are there? So the A option, which is 2520, B option is 4120, C option is 3100, and D option is 1000. Okay, so you will try attempting this question for a while and then we will start solving this. So give yourself some time to solve it. So 2 minutes for that. So what have you given? The word cricket. Right? So what we do, we should always write the number of times the word from cricket is coming. Okay, so how many C's are there? So you have to just count out the source. I'll write this as source. Okay, so there is C, there is R, there is I, there is this C, there's this K, there's this E, and there's this T, right? So number of time, how many number of times does C comes? So instead of this, rather than writing this, what I will do, I'll write here 2, right? How many times in cricket R is coming? So this is coming in one time. How many times I is coming? I is coming one time. So since he was already there, we cut it. So it's better to, I'll just cut it with this. And I have written this, counted here itself. Okay, yeah. Coming back to our question, how many times K is coming? Only one times. T is coming two times. T. Whosoever can do that thing, they can do it. So from these words, so the number of ways. So what is number of ways slash words will be? So how many total number of words? Factorial divided by the number of times factorial. This is multiply. Okay, this is actually the factorial. Okay, yeah. Are we online? Yeah. So let this be, I'm making it up. So let this be W, number of words, total number of words. So number of words will be CRICKET. So 1, 2, 3, 4, 5, 6, 7. So number of words equals to 7. So what it would be? It will be 7 factorial divided by, multiply these things, 2 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. So please calculate this. The answer will be 7 into 6 into 5 into 4 into 3 into 2 into 1, and here it will be 2 into 1. So this part will cancel by this. The answer will come around. You should solve it. The answer should come around. So the answer is A. So what we did, you should always know that where the question is asking, so number of words they are asking, count the number of times how much it is asking you. CRICKET, it has 2, 1, 1, 1. Number of words, total number of words divided by the logic behind that. Can I give you another question on this so that you can get an hint? So let this be a part of question number 1. The other part is same way, number of words with phenomenon. Okay, I'll just give you the answer for this. You like a way hint kind of thing. Just write whatever things we have. H is the first time, E is there, N is there, O is there, M is there. I am not writing E, so I am cutting E and I will write this as 2. I am cutting N and I am also writing this as O. I am cutting M, I am writing this as N. I am cutting N and I am writing here it is 2. So these are all one thing. So W will be equals to, count the number of words. Count the number of words. words will be equals to. So number of words, so 1 2 3 1 2 3 4 5 6 7 8 9 10 10. So it will be 10 factorial by 2 factorial 2 factorial. This would be the answer. Okay, I hope we are on the board. Let me see, I am in line or not. Yeah, so going by another question. Let's see the question. Okay, this is a good question. The question says the internal energy which we call as U from the partition function. Oh, before this, I'm just rubbing, I'm so sorry. So before this, so you should always know what it is. So I'll take this, I'll give you this as a question only. So the question is a quantity that relates the microscopic thermodynamics property to the macroscopic thermodynamic property. What this property is called. So always remember this. This property is called partition function. This you must have done, but I should have introduced this before going to any questions related to the partition function. Okay, so that's why this was just for the addition of it. I have added this question. So let's now go to this question. So this question, so what we have done question number 1, 2 and 3. Okay, so question number 3, the internal energy which we generally call as U from the partition function Q can be expressed in terms of KT and Q as. So this, I won't be giving any option to this, so you should try this. I'm giving you 2 minutes to solve this, so yeah, try that. This is a very important question. Everyone should know this question. This will be a very long question as well, so try to do that. Try attempting that. It is a good question, so try attempting that. There will be few direct questions which I'll be taking, and few normal questions which I'll be taking. So this is one of those direct questions. The previous one was one of the direct question, and this would be what we say, a detailed question. So can we start this question? Because it will take time. I will myself start this. You should follow this. So as we know, as per Boltzmann distribution law, the probability function is equals to e raised to the power ej by kt. So this will become and divided by the partition function. So as we know, q is always equals to j equals to 1 to t e raised to the power ej by kt. So that is like the summation of it. So what this will become? It will become kt by summation of 1 n equals to 1 to t, or sorry, j equals to 1 to t ej by kt. This much we are in line. So what is average internal energy? It is, if you remember, J equals to 1 to T Pj Ej. So now can we write? We already know Pj. So bringing this to here, J equals to 1. How am I bringing it? You can understand this. So let me, okay, now it's better. I'll take this, J equals to 1 to T. So already we know this will be e raised to power ej by kt, and I'm just taking this as q only. This is ej. Okay, so this is in multiplication. So I am taking 1 by q out. Now this will be j equals to 1 to t ej into e raised to the power minus ej by kt. So as we know already, since 1 by kt is equals to beta, I will write 1 by q j equals to 1 to t ej into e raised to the power minus beta into ej. Are we in line? We did nothing. We already know what was P, what was EJ, just we have summarized it. Q was a constant, so I just took Q out and I have tried to make the simpler calculation. Are we in line? Yes or no? Right? So now other thing is, so U equals to 1 by Q, J equals to 1 to T, Ej, e raised to the power minus beta Ej. So d by d beta of U will equals to be 1 by d beta 1 by Q j equals to 1 to t ej e raised to power minus beta ej, which implies du by d beta is equals to j equals to 1 to t ej e raised to power minus beta ej. Are we in line with this or not? I'll just write it again. So this I am just circling this. Okay. So now we will use u equals to minus 1 by q dq by d beta, where u equals to minus d of ln of q by d of beta. Now, as we know, beta is equals to 1 by kt. Therefore, are we in line? I guess so, yes. Therefore, d beta by dt is equals to minus 1 by kt square. And as we know, u equals to b ln q by d beta. Now we just have to see. Now we have to differentiate. With d beta by dt. So u into d beta by dt is equals to d ln q by d beta to d beta by dt. So actually this should be multiply. Okay. So we are at 1 by kt square is equal to minus d ln of q by dt. So u by kt is equals to t d ln of q by dt. Which implies u is equals to kt d ln of q d ln t, or d ln t is 1 by t. Let that be there. So this will become kt square by q dq by dt. How we got this? d of ln q is 1 by q dq and d of ln t is equals to 1 by t dt. Okay, are we in line? So what we got? Therefore, yeah, this is important. It is square q dq by dt. Very, very important formula in statistical thermodynamics. Foundations of StatMark or some other StatMark most important formulas, one of important formulas actually. Okay, so I'll just write this and here this. It's an important question, so please take some time to go through all of it. What we did is, I'll take a good pen. So what we did, I'll just scribe it. We already knew PJ, already knew this. We went to describe what is PJ by expanding it with Q, and we already knew that U average is equals to PJ EJ. So in this, nothing we did not open it, we left the Q out and let Q comes out. Q has come out. Okay. Now here we just turn 1 by KT equals to BT, and then we got this solution. So what we got, U equals to 1 by Q of EJ e raised to by minus beta EJ, right? So 1 by J equals to 1 EJ BJ is equals to E raised to. Now what we do is we will differentiate d raised to the power average of U equals to 1 by theta B. So differentiate this thing and we got a formula which will tell us something. Now we will use, we already knew this thing, 1 by Q dQ by d beta, right? So we saw this and we know now 1 by Q. So since 1 by Q dQ is equals to d ln of Q, so we substitute that and we found that as we know beta equals to 1 by KT, so we differentiate. Okay, so when we did that, U equals to minus dQ by mg, and then the same thing, differentiation, and we got finally minus d ln Q by dt. So t dt is cancelling out and we got d ln T by T, and we just wrote by taking these two approximations, two problems. Okay, take another 1 minute to understand this, that what was the problem was and how we solved it. Now, after taking a very long question, I will keep a short question or a conceptual question it is. So I just want an expression. So these are like, when I'm saying a conceptual question, you should remember these all things. Entropy. So when we were using classical thermodynamics, we were saying entropy is basically randomness, right? But partition function Q is okay. So I will tell you about this thing. So when we were using classical thermodynamics, we were always denoting entropy with, so before this thing, I'll just explain something. So if it is like classical thermodynamics, we always used to say entropy is basically randomness. But we never had some definite definitions of it, which came actually from that entropy is actually randomness, but it is also the number of ways to calculate how many microstates are there in the in that present ensemble. So from classic to thermodynamics, from classical to, if I'll say, take this, from classical to molecular or statistical thermodynamics, which joins this is partition function. And it actually also tells the entropy calculation. So it's a bridge. Partition function is a bridge for anything. So it's a bridge for any possible thing. So keeping this aside, you should always remember, so answer 4. So what is the expression? The expression is S equals to KT ln of Q. Remember this. Okay? So always remember this. This is a bridge between the KB, like the classical thermodynamics to the molecular thermodynamics. Q is that basis. So yeah. So shall we go to the next question? You just revise all the things. Let's take few good questions. So from here there'll be like questions on good questions. So let's start solving it. So taking the 5th question. So suppose that on a given day you sample the distribution of the colors of the socks that 30 people are wearing. So figure 1, I'll be making that figure 1, which shows that figure 1 shows that. So I'll make that with Another color, maybe red. So first, initially, I will be drawing it with so taking this as some bridges. I'm trying to make it as real as possible so that you can understand this. And so it is depicting like somewhat like this. Okay. So it is like taking the similar values. We will be making this as well. So this is the values which we'll be taking. So what we have been given, this is equals to 2 by 10, this is equals to 1 by 10, this is equals to 3 by 10, this is also equals to 3 by 10, and this is equals to 1 by 10. So what it is asking from me is that, so it is saying the entropy can be computed from any distribution function even for colors of socks. So entropy is basically can be done for anything, whether it is, so these are like different socks. So one is white, I forgot this, the other is black, the other is blue, the other is red, the other is brown. Okay, so whether it is white, so white is W, red as R, then another is blue, which is sorry, this is black only, the other is black, we will define that by BL. This is what the other one is brown. 1 2 3 4, the other one is, so let's take brown as well, let's make a good brown color. So brown with BR, and the last color is green with G. Okay, so we have to find the entropy of these. it is saying calculate the entropy of this distribution. So shall we start? It is saying that there are different colors which has different partition functions where or the probabilities which has already been given to us. So how shall we proceed? You can try for a minute and then we will start. The basic formula which you have to use, so I'll write. S by K is equals to minus of I equals to 1 to N Pi ln of Pi. So already we know the probability. So for this question, it will be S by K is equals to minus of 0.2, because if you can see the first thing is ln of 0.2. So okay, let me write it more nicely here. If you can start by yourself rather than I'll be writing answer here, I should give you the formula first. That I equals to 1 to 5 Pi ln of Pi. So this will equals to this will the first Pi1. So first let's see for black and everything, it has been given. The probabilities have already been given. So let's start with the white only. So it would be only brown. So whatever we have been given, so minus 0.2 ln of 0.2 minus 0.3 ln of 0.3 0.1 ln of 0.1 minus 0.3 ln of 0.3 minus 0.3 ln of 0.3 minus of 0.1 ln of 0.1. So if you calculate this, S by K will approximately be coming out as 1. So S will be equals to 1.5 K. This is the answer. Let's try solving another question. So what my next question saying? Let's start that. So for a sequence of n distinguishable objects, the number of different permutations W are expressed as so this is also a conceptual question we should know. So permutation permutations equals to number of factorial, which will be equals to n factorial. This is the answer. Are we in line? Now let's take another question. Question number 7, which will be a very common question which has been asked now and then. Perhaps the simplest statistical mechanical system having cooperativity is three-level system that is shown below. So this is energy and this is degeneracy. So degeneracies and energies. So energies have been given to us as 3 epsilon naught and 0, and this has been given as gamma 1 and 1. So the question they have asked which they have asked is this: an expression for the partition function q as a function of energy epsilon, degeneracy gamma, and temperature T is. Please try to attempt by yourself initially and then we will follow. So answer 7. Partition will be equals to, if you know the degeneracy, sigma of I equals u1 to n e raised to power minus ej by kt. Ej is equals to 3 epsilon. Oh, sorry, I am writing with a black pen. I should remove this. I am so sorry. I have not seen that. Answer 6. Answer 7. It will be equals to partition function q will be equals to I equals to 1 to n degeneracy into e raised to minus ej by pj. Now we know ej equals to, how much is ej? We know it is 3 epsilon naught 0 for degeneracy gamma 1 and 1 respectively. So solving this, QL will become E equals to 1 to 3 degeneracy into E raised to the power EJ by PJ, which will be equals to, let's start solving this. So first will be gamma into E raised to the power minus 3 epsilon naught by KT plus 1 into e raised to the power epsilon naught by KT plus 1 into e raised to the power 0 by KT, where Q now will become lambda into 3 epsilon naught by KT plus e raised to the power epsilon naught by KT plus 1. This is the answer. Now another question. Let's do a similar another question. Question number 8. So now let's try doing the similar question on that line. Now you have been given experimental studies for a simple non-polar gas A indicate that when two molecules of species A are two molecular diameters apart, the potential energy is minus 8 into 10 raised to the power minus 60 arc. Consider. Now, two simple non-polar molecules or species B when these two molecules are two diameters apart, what is the potential energy in Earth? Consider, so this is the question basically. Consider the general function to be Lj 12.6 potential, critical data for A and B are. So going ahead, A, B, TC, Kelvin, PC, bar, and VC, centimeter cube mole inverse. This is 120, this is 180, 31.9, 36.1, 90, and 120. Please try doing yourself and you will soon get that. So we are already given, I hope you have tried. So we have already been given the potential energy of AA is equals to minus 8 into 10 raised to the power minus 16 R. So as we know, by molecular theory of corresponding states, pi II by epsilon I is equals to R by 6I, where R is equals to 20 to sigma. So tau pp will let's take it like that. AA by epsilon A will be equals to F of 2 . Now tau BP, it's a potential energy we were in week 5. Sorry for this disturbance. Now, doing exactly the same, the potential energy of dB by epsilon B is equals to function of 2. F is a universal function. So you should always know this. F is a universal function. So dividing above expression, AA by potential of BP is equals to epsilon A by epsilon B by epsilon A, F of 2 by F of 2. This will cancel out, or we can write oppositely BP by AA is equals to epsilon A Now we know, since epsilon by K is equals to 0.77 critical temperature, taking the generalized function F as the Lennard-Jones potential. So now this will become tau AA as TCB by TCA, since silent A is equals to 0.77 CA by K. Epsilon B by K will be equals to 0.77 TCB. So this is the explanation. Now this will be, we already know how much it is, into TCB. TCB, if you'll see, it is approximately 180 by 120. The answer will come around like good question. Answer. Please go through the question. Let's do that together once. We have already the tau AA, tau BB. It's a good question actually. So we already have tau AA, and by molecular theory, we already know that F is R by 6A when they say LJ potential. So we have taken two parameters. So F of 2 will get cancelled, and epsilon A by epsilon by, because the dimolecular white out. And then when we will divide that, and as we know epsilon by K is equals to 0.77 TC, we just replace epsilon A by TC and TCAB. And then we had the options, so we got this answer. Now let's do an easy question. Question 9, which is given a two-state system in which the low energy level is 300 calorie per mole. The high energy level is 1500 calorie per mole. The temperature of the system is 300 Kelvin. What is the partition function Q? So what you have been given is a two-state system already. So it will be an easy thing that where the low energy level is 300 and the high energy level is 1500 for temperature equals to 300 Kelvin. So from the question number 7, we did that. How much we will get? The Q will be equals to 1 to 0 at will be equals to e raised to 1 e2 minus e1 by kBT. Q equals to 1 this will be the answer. This is very similar to the question number 7 which we did. Now we will lastly go to our 10th question. So I hope this is an easy question, and now lastly we will solve our 10th question. Consider a spherical, non-polarizable molecule of radius 3 angstrom, having at its center a dipole moment of 2 dB. This molecule is dissolved in a non polar mixture having dielectric constant equals to 3.5. Calculate the energy that is required to remove this molecule from the solution. The expression for energy is this. E equals to 1 by a cube epsilon r minus 1 by What A is radius of molecule and epsilon r is the dielectric constant. Please try solving this. And mu is dipole moment. Please take this question properly and then we will try to solve. So what is the, so rather than writing it, I'll write it properly. Consider a, a spherical non-polarizable molecule of radius 3 angstrom, where E is equals to 1 by A cube where A value is equals to 8 centimeter, epsilon r is equals to 3.5 and mu is equals to 20. E is equals to 4.61 into 10 raised to power minus 21 joule per molecule. So as we know, one molecule occupies 6.023 into 10 raised to power 23 molecules. So one molecule is equals to 1 upon 6.02 in the mole which is equals to 1.66 into 10 raised to power minus 24 mole. So E will be equals to so basically why this you have to find out, because E will be equals to 1 by A cube, so 3 into 10 raised to power minus 8 का cube epsilon r minus 1 3.5 minus 1 into 7 minus 1 into 20 square. So this was this. So E will be equals to 4.6 into 10 raised to power minus 21 divided by 1.66 into 10 raised to power minus 24 joule per mole. So answer will be 277 joule per mole. So in this whole lecture, what we have read is, first we understood few PNC questions where we get an answer, what is entropy, what is bridging, where everything goes, and I have taken few important questions where we learned. So in question number 1 we learned how to do permutation and combination. Number 2 we learned the permutation and combination, where we should know first of all how to calculate source and remember this formula. Number of so first of all, it is like non-repeated numbers or number of words which we can make, so that you should remember. So number of words will come around. So we did for 2 examples and we were able to relate. Then there is this property of partition function which relates the microscopic thermodynamics to the macroscopic thermodynamics. Then this derivation which we did, which was on internal energy and partition function, which has been given in terms of KT and Q. So you have been given the partition function Pj and you have found out Ej and Pj, which have been clearly explained how Pj came into picture, and which we have tried out giving 1 by Q as Ej into e raised to power minus beta epsilon j. So when we tried out finding du by d beta, we got some expression in terms of Q and beta. So and then we differentiated both the things and we finally end up getting u equals to kt squared by partition function into d partition function by dt. Then we should always remember entropy, and which actually the partition function which relates it, and entropical, how much S equals to kt ln q came into picture. Now we got to know what is, when we know S equals to kt ln q, so we know that ln w is equals to pi. Ln w equals to pi, ln of pi, and that to minus. So we have just replaced it by that, and S by k is equals to summation of 1 to n the probabilities into ln of pi. Next we got what is called permutation, what is exactly permutation is, and then we learned about energy and degeneracy. So basically we did a 3 model system and 2 model systems where degeneracy energies has already been given to us, where we have just multiplied. Just remember this formula, which is a good formula. So degeneracy into epsilon minus e raised to power ej by pj. So then we did a 2 model simulation where we were given potential energy, and then we just divide both of it and relate by epsilon by k. Okay, And then lastly, we did a two-state system, which we have already explained. And last but not the least, we did a energy calculation where A, B, and C has already been given to us. These values has already been given to us, and we have just put into the functions and we found out the values. So, and they were asking for one molecule, so, and or the number for one molecule, so we just calculate if we got the answer in joule per mole. So we got that in joule per mole, because we know that 1 mole consists of 6 into 10 raised to power 23 molecules, and we have already calculated E in terms of that. So we try to do for the one molecule thing, because we already got this value for G into, so this we got it for per molecule. We wanted to convert into moles, so we tried to compare it with the moles. So when we got it, the answer came out around to be 2777 joule per mole. So this is the answer which we did. Thank you everyone for attending the class, and I'll be uploading this along with the YouTube video, and you can find both of these, and then we will meet with week 6 lectures. Thank you.